So today we are continuing with paper 4 from the 0620 IGCSE specimen from 2023. This is question 4 that you're seeing on screen. So sulfuric acid has many uses. Sulfuric acid is a strong acid. Define the term acid.
An acid is a proton H plus donor.
Right, so just get my green ink over here. So a proton donor. And define the term strong acid.
A strong acid is an acid that um, that completely ionizes into ions in aqueous solution.
So you're correct, but the only thing is instead of ionize, you want to use the word dissociates.
Okay.
Alright, dilute sulfuric acid is used to make salts known as sulfates. A method consisting of 3 steps is used to make zinc sulfate from zinc carbonate. Add an excess of zinc carbonate to 20 centimeter cube or 0.4 mole per decimeter cube of sulfuric acid until the reaction is complete. Filter the mixture. Heat the filtrate until a saturated solution forms and then allow it to crystallize. Now suggest 2 observations which show that the reaction is complete in step 1.
Hmm. The uh, the bubbling stops.
So instead of bubbling, you want to use,
Fizzing.
yes. Because it's a
Um,
carbonate. So
yeah.
carbonate plus acid is going to give you carbon dioxide gas.
Yeah.
That's where the fizzing is coming from. And
Excess zinc carbonate remains undissolved in the mixture.
good, very good. So that's ZnCO3. Remains undissolved. Alright, state why it is important to add an excess of zinc carbonate in step 1.
So the uh, acid neutralizes.
It's not a neutralization reaction.
Uh,
So that all of sulfuric acid has reactant.
Good. Or you could say used up. Alright, define the term saturated solution.
Mm, it means that saturated solution is a solution in which no more solute can be dissolved in the solvent at a specific temperature.
You've been revising. Hmm?
Sorry.
You've been revising.
Yeah. I mean, I can't take risks.
You shouldn't, and like this is good. All right, name another zinc compound which can be used to make zinc sulfate from dilute sulfuric acid using this method.
Zinc oxide
Zinc oxide.
Okay, so zinc oxide works.
or zinc carbonate.
Zinc,
Carbonate.
you already use zinc carbonate.
Yeah.
The other option is zinc hydroxide. Good.
That was quick.
Suggest why this method would not work to make barium sulfate from barium carbonate and dilute sulfuric acid.
Because it is insoluble.
Right, and so the method involves filtering the mixture and then heating the filtrate, right? So you'd filtrate the
Yes.
mixture, and this is where the barium sulfate would end up, right? So you
Yeah.
won't be able to. So you want to use the same steps, and so barium sulfate is insoluble, and so you can't really go on to step 3. Oh, titration.
Oh
So
god.
in a titration, a student added 25 centimeter cube of 2 moles per decimeter cube aqueous sodium hydroxide to a conical flask. The student then added a few drops of methyl orange to the solution in the conical flask. Dilute sulfuric acid is then added from a burette to the conical flask. The volume of the dilute sulfuric acid needed to neutralize the aqueous sodium hydroxide was 20 centimeter cube. So a good thing you want to do during exam is underline the information. So you've got sodium hydroxide, so that's NaOH. Scroll up a bit, right? So this is NaOH, right? And you've got 25 centimeter cube or 0.2 mole per decimeter cube. And then you've got sulfuric acid, so that's H2SO4, and you've got 20 centimeter cube, obviously, right? Sorry, the volume is known, the molarity is unknown. Okay, so the reaction is shown by this equation, and they've given you a balanced equation. First of all, what is the color of methyl orange in aqueous sodium hydroxide?
Yellow.
Yellow. So it is yellow in alkaline solutions. Now, determine the concentration, right, of the sulfuric acid in grams per decimeter cube using the
Could you scroll down all the way so I can see the all three questions?
therefore,
Yeah, it's four.
right? So the first step is calculate the number of moles of aqueous sodium hydroxide added to the conical flask. Then calculate the number of moles of dilute sulfuric acid added to the burette. Then calculate the concentration of dilute sulfuric acid in moles per decimeter cube, and then the concentration in, right? And so this is a total of 4 marks. It's 1 mark for each step,
Okay.
right? And this is a scenario where the rule of ECF or error carried forward will apply. So if you make a mistake in one step, you lose marks for that step, but then using your answer, whatever you got, you do the following steps and you do them properly using that initial incorrect value, you can still get marks.
Okay.
Obviously, we don't want to.
But
Uh,
wouldn't that wrong answer lead to another wrong answer?
well, it will be wrong in terms of the expected answer of the mark scheme. But for example, if the answer was supposed to be 30 and I got 27, that's obviously wrong. So I don't get a mark over here. But then I use 27 in the next part and I do the working correctly and I get something else. Because my
Even if the answer is wrong, as long as the calculations are right, you say we
as
get a
long as
mark.
my calculation and the answer according to my value, which was 27, is correct,
Oh, okay.
if my answer is correct according to my value, which is 27.
Okay, even if it might not be the same, like
Yeah,
correct
so
answer,
so
but
it obviously won't be the same as the mark scheme.
yeah,
But if it's correct according to my working, right? So if with 30 I was supposed to get, right, number of moles was, I don't know, right, 3, but I got 2.7, right? So 2.7 is wrong in terms of the mark scheme, right? But it's correct according to this. I'll get a mark. Now if I mess up again and I get 2.5, that's wrong. And I won't get ECF this time, most likely,
yeah, okay,
because I made one mistake after the next. So I'm just, right, this shows that I really don't know what I'm doing.
yeah,
All right, so you have aqueous sodium hydroxide 25 centimeter cube and 0.2 moles per deciliter. So 25 centimeter cube is how many decimeter cube?
0.025.
And you have 0.200 moles per decimeter cube. Right, so how many moles do you have? Volume into concentration?
Yes.
Right, so 0.025 multiplied by 0.200. And what's the answer you're getting? 0.005? Anyone?
yeah, 0.005.
Right, so that is correct. Now calculate the number of moles of dilute sulfuric acid added from the period. So look at the mole ratio. Right, it's 2 is to 1. Right, so if
Yeah,
it's 2 is to 1, that would be 0.005,
divided by 2.
which will give you what?
0.0025.
Right, 0.0025.
But do we need to write the 0 after 5?
Huh?
Do we have to write the 0 after 5 as well?
For which 5?
0.00250.
Well, that 0 doesn't really mean anything.
Okay.
Okay. Then next step, right? Now you know the number of moles. So what is the concentration?
Could you like zoom out so I can see it all together if you don't mind?
Zoom out.
A little, not too much. Yeah. No, only the four parts. Yeah. Okay.
It would be 0.125.
Mm,
Right, so you got the number of moles. So what is the formula for concentration?
concentration equals to moles over volume.
Volume in decimeter cube, right?
Yeah.
So that would be 0.0025
divided
divided
by
by
0.
20 into 1,000. Why is it into 1,000? Because it was 20 over 1,000. Right? So 0.0025 divided by 20.
Will it give us 0.125?
Yes.
Okay.
Now, if you have 0.125 moles, what is, right? So you need the MR of H2SO4, right? So that's 1 into 2 plus what is sulfur?
32.
Let's just check. So yeah, 32. H2SO4, right? And then 16 times 4. So that gives you how much?
98.
0.26. Uh,
Right, so you got 98 grams, right? And then you do 98 multiplied by 0.125, and that will give you how much?
12.26.
And that's your answer. Right? I hope there are no difficulties with this working.
No, not really.
Aram, all good? Yes?
Yes.
Okay. All right. A student investigates the progress of the reaction between dilute hydrochloric acid and an excess of large pieces of marble calcium carbonate using the apparatus shown. A graph of the volume of gas produced against time is shown. Right? State how the shape of the graph shows that the rate of reaction decreases as the reaction progresses.
Is it okay if you show the first part as well so I can see? Uh, the gradient?
Yes. What about the gradient?
Okay. Like, the gradient or the slope of the, like, it decreases over time, which shows the rate of reaction is slowing down. Am I wrong?
You are absolutely correct.
Oh, okay.
Suggest
I let, I let Haram take over.
you don't want to,
Yeah,
you don't want to take all the spotlight.
yeah.
All right. Suggest why the rate of reaction decreases as the reaction progresses.
Do I have to answer?
Huh?
Do I have to answer?
Well, that's what Sobi is saying.
Uh, the concentration of
Am I?
is
Haram, if you were responding, I couldn't make sense of it. Could you repeat that?
the concentration of gas are decreasing.
The concentration of what is what?
Reactants
Okay. So, right, you want to say, right, not just reactants, but if you read the question, the calcium carbonate, the marble pieces are in excess. So that's not going to be the limiting reagent. The limiting reagent will be the hydrochloric acid. So you're going to say,
Um,
right, the
less
concentration
polish.
of HCl,
Okay.
right, is decreasing. Or you could also say that there are fewer number of HCl molecules to react with the calcium carbonate.
Yeah.
Okay. Reduce the time at which the reaction finishes.
350 seconds.
No, the reaction finishes when you see no more gas being produced.
100.
200 seconds, right? How do I zoom out? Right. So 200. Now, the experiment is repeated using the same mass of smaller pieces of marble. All other conditions are kept the same. Draw a line on the grid that to show the progress of the reaction using the smaller pieces of marble. So where are we going to draw the line?
At the gradient?
No, we're not talking about gradient. We're talking about the results of a new experiment, right? Everything's the same. The only thing is that instead of having large pieces of marble, now you've got smaller pieces of marble, right? So you're conducting the experiment again, but this time you have smaller pieces of marbles. So what kind of graph will you see?
Can you please repeat that?
Hmm?
Can you please repeat that again?
You are conducting this experiment again.
Yeah.
Everything's the same. The only change that you've made is instead of using large pieces of marbles, you are using small pieces of marbles. So, right, what kind of graph will you see over here?
It would like speed up the reaction.
Okay, so it will happen more quickly, which means what?
Yeah.
That it will reach the maximum volume in lesser time
Yeah.
and it will give off more gas more quickly.
Yes.
Do you agree, Sobi?
Honestly, I don't know.
Okay, so this is what it should look like.
It would be like steep.
Okay, not quite that. Something like that. Right, it's going to be steeper and it's going to reach the final volume more quickly. Okay, so obviously when you draw it on paper it will be more neat or accurate. It could even be, let me try once more. So you need to start at the origin. There, something like that perhaps. Okay,
Yeah.
so you get 2 marks for that. Okay, the original experiment is repeated at a higher temperature. All other conditions are kept the same. The resulting increase in rate of reaction can be explained in terms of activation energy and collision between particles. Define activation energy.
It is the minimum amount of energy that a reactant particle must have for a collision to happen more
Right. So it
successfully.
is the minimum energy that reactant particles need to react. Now, because right, this is correct, but because they want it in terms of activation energy and collision. So instead of saying reactant particle, you want to say colliding particles.
Okay.
The minimum energy that colliding particles need to react. Now, explain why the rate of reaction increases when temperature increases in terms of activation energy and collision between particles.
Increases the rate of planet.
And again, what happens? Could you repeat that?
Like when the temperature increases, kinetic energy also increases.
Okay, so the kinetic energy of the particles increases.
So they gain like more energy
Well, you already
for the
mentioned that
collisions.
it's the same thing.
So like yeah, so more collisions happen more quickly.
More frequent collisions.
So kinetic energy of particles increases, right? You
The
got
second,
more frequent collisions.
yeah. May I give the third point?
Yeah.
Successful collisions.
Okay, so what does successful collision mean?
Mm, like greater than or equal to the activation energy.
Right, so a greater percentage of collisions or the greater percentage of particles have energy greater than the activation energy.
And rate of reaction increases.
Yeah, well, that's already given, so you don't need to mention that.
Yeah.
So you can either say it's collisions or particles have energy greater than. Now you can use established symbols, right? You can write EA for activation energy, right? And the examiner will correct it because that is an established symbol. Okay.
Yeah,
All right, we're almost done. We have questions 6 and 7 on. Let's do this.
let's
Al-
go.
Alkynes and alkenes are homologous series of unsaturated hydrocarbons. Now, right, obviously they can give you something in the exam that you are unfamiliar with, right? But on a side note, if you remember, I think it was, I'm hoping it was you guys, right? But alkenes are the ones that have a double carbon bond. Alkynes, although it's not in your syllabus, I may have mentioned, I don't remember, but they've got a triple bond, right?
Yeah.
And they're also mentioning it over here, obviously. All alkynes contain a carbon-carbon triple bond. Complete table 6.1 showing the information about the first three alkynes. So you've got ethyne. Obviously, you cannot have methane because a single carbon cannot have triple bonds with itself, right? So ethyne, and then you've got but one-ine, right? And so it's worth 2 marks. So let's do this one
Propane,
first. This will be what?
propane or
Propane,
propine, if I'm pronouncing.
propine, good. Propine, right? So remember how to name these guys. Okay, and how many carbons do we have over here? You've got 1, 2, 3, 4. You've got C4.
C4 and N6.
1, 2, 3, 4, 5, 6. Right, so CN, HN plus 2. Well, not quite. CN, HN, CN, HN plus 1, CN, HN plus 2. Compounds in the same homologous series have the same general formula. Right? Give two other characteristics of members of. So first, what are characteristics of a homologous series?
Similar chemical properties,
Similar chemical properties. Okay.
same functional group,
And they have a high boiling point.
They have what?
A high boiling point.
Not necessarily.
Okay. It increases like with molecular mass.
Okay, so it could be same functional group and similar chemical properties, which Sobia suggested, right?
yeah,
And then, right, uh, they there is a so what you're saying, Adam, is that there's a trend in their physical properties. They start off perhaps as gases and then liquids and then solids. Okay, and obviously then their melting and boiling points will be accordingly. So the larger the molecule, the higher the melting and boiling points, right?
yeah.
Now you need to deduce what the general formula is.
Say that again, sir.
You need to figure out what the general formula for these guys is, right? We can write this much at least. We can say it is CN, obviously.
Yeah.
But what about,
N
huh?
H2N.
Okay, CnH2n is alkenes, right? So CnH2n plus 2 is alkane, CnH2n is alkenes, right? This is not 4, this is 2. So it's 2 less than the double.
For alkynes, it is like a specifically a triple bond, right?
Yeah.
-2. You have to write -2 there.
How did you figure that out?
I mean, that's the general formula, isn't it?
It is, but how did you figure it out? Or did you just know it?
Yes, I went with the gut.
That's an odd gut you have.
Yeah. Actually, not gonna lie. Yeah, I knew that already.
Okay. So, right, to figure this out, you could sort of rack your brains over this, like, oh, CnH2n would be 4, but this is 2, so it's 2 less. And then CnH2n would be 8, sorry, 6, but this is 4, which is again 2 less. And then H2n would be 8, and this is 6, so it's 2 less. And so you could get that. Also, you could see alkanes which are completely saturated are CnH2n plus 2. Then you got alkenes which have a double bond, so basically, right, instead of having full bonds, right, so each of the carbon loses one of its single bonds to make a bond over here, right, and that was potentially two hydrogens. So you're losing two hydrogens. So now it's just CnH2n. Now what if you make a triple bond? Then you're losing two more hydrogens, right?
Yeah.
And so that would make it CnH2n H2N minus 2. Alright, so two ways to go about it. Alright, alkynes are unsaturated. Describe a test for unsaturation.
Yeah, Haram, he's asking you.
Yes.
Okay, you know what? We have to write for test. We have to add bromine in water.
Bromine, aqueous bromine or bromine solution.
Yeah.
Okay. And what would the result be?
It
Uh,
decolorizes.
there will be orange or brown. The orange or brown bromine will decolorize.
Oops. The color. Decolorize. Okay. Ethene and butene are alkenes. Draw the displayed formula of butene.
Can I answer this one?
Yes. So how many,
Hydrogen with
wait, how many carbons are we going to have?
4.
Now tell me.
Uh, at first, like, there will be a double bond.
Over here.
Yeah.
Sophia, do you agree?
Yeah, I do agree.
Okay.
And before each carbon, there will be a hydrogen.
No, wait. Actually, uh, okay, no idea. Okay, go on.
Yeah, so you got a double bond between the first two carbons, then
Uh, Before the first carbon, there will be a hydrogen with a single bond.
is this what you're talking about?
Yeah.
And single bonds between the carbons?
Yeah.
Is wrong.
There will be like 3 carbons written at first
It is wrong. Why is it wrong?
because the butene.
Because you number it from the shortest, like the closest to the end, right? So this is carbon 1, this is carbon 2. So you'll number it 1, not 2. Right? So this will be but 1ene.
But means there will be 4 carbon atoms in the chain, and the double bond starts at the second carbon atom.
Yes. And so, right? And so what we're going to do is have a double bond here and a single bond. So you've got 3 hydrogens here, single hydrogen here, right? And another single hydrogen here. And so, yeah, that's but. And so right now, because this is even sort of, you number it from either end and you're getting the double bond at carbon number 2, right? So obviously, as I explained to you guys during class, that your numbering should be from the shortest end.
Yeah.
for the double bond or for the functional group. And so this is but.
Yeah.
All right, draw a dot and cross diagram to show the molecule of ethene. Show outer shell electrons only.
There
So,
are two electrons in carbon.
so first you've got carbon, two carbons, and we have, right, so it's obviously a covalent molecule. So I'm drawing this big so I've got space for the, right, and we've got hydrogens. So that's too big, a bit closer. Better, okay. And similarly over here, so far so good.
Yeah. Yeah.
Now tell me about the electrons.
Two electrons.
8 electrons in its outer shell.
Yeah, but how?
4 shared with others C and 2 shared with each
So
of the two
so what do I draw with? Like, do I draw four dots? Do I draw four crosses? What do I draw over here?
crosses.
Four crosses?
I know. Wait. Uh.
One cross,
One cross and
one dot.
so that's two electrons.
Yeah.
That's it.
And we will repeat that again.
All right. So you got a double bond,
Yeah.
and these guys will be that look okay?
Yeah.
Okay. Ethene can be converted to ethanoic acid by a two-stage process. In stage one, ethene is converted to ethanol by catalytic addition. So you're adding water to ethene to get ethanol. Suggest why stage one is called an addition reaction.
Because it speeds up the reaction.
Huh?
Because it speeds up the reaction.
No.
We are adding like catalytic addition.
What does addition? So, what is 2 plus 3?
5.
Yeah.
You're putting both of them together and you're getting one answer.
Addition reaction is basically putting two molecules to react together to form a single product.
Yes, a single product is formed. A catalyst is used in stage one. State one other condition that must be used.
High temperature or high pressure?
Right. So let's say we could go with high temperature, but right. You, so temperature, what they've said in the uh, mark scheme is temperature above 100 degrees. Now, 100 degrees Celsius technically is not really high. And this is simply from the text, right? So this is something you need to know. All right, state what must be reacted with ethanol to form ethanoic acid.
Oxidizing agent.
What one?
Uh,
You can't get away with just saying oxidizing it. You're correct, but which one?
is it two of them? Wait.
It's one thing, but it's got two parts.
It can be reacted with oxygen, right?
No,
Acha, no, wait. Acidified potassium what was that? manganate something.
So it needs to be aqueous, potassium, manganate,
We use oxygen
semen.
presence of catalysts as well.
Huh?
We can use oxygen in the presence of catalysts as well.
Can you?
I am asking.
I don't know. I mean, if that's an alternate route, that's not what's given in the book. So, right, whether or not that's possible, we can look it up, but that's not something you'll be using as your answer because your answer needs to be in accordance with the syllabus.
Okay.
Right? Okay. Final question. 5 marks. So this should be quick. Carboxylic acids can be converted into esters. So you're reacting that with so how do you get esters?
Mm,
Right? You have a carboxylic acid, and what do you react it with? I mean, it's given over here. Propanoic acid and methanol react to
yeah,
form an ester of the molecular formula this.
yeah.
Oxygen.
No, alcohol.
Oh,
So it will be methyl propanate, propanoid. I
Good,
don't know how to pronounce it.
good, good. Propanoate. Displayed formula. Right, so the propanoate is going to come in first. You got three hydrogens, and over here, because the exam, you draw the whole thing out in detail.
And there will be a double bond. Okay, first you draw that.
Yeah, it will be what?
The double bond between the CO. Yeah,
Yes,
yeah, exactly.
and then
A single bond, CO. Yeah, and C H. Yeah, yeah. Okay, and then between. Okay. Yeah. Okay. Yeah.
right, and so as I see, you got two oxygens, you got four carbons, and 1, 2, 3, 4, 5, 6, 7, 8. So that is C4H8O2.
Hmm.
Remember that while naming it, you put the alcohol first. While drawing it, you put the carboxylic acid first.
Okay.
Name another ester with the molecular formula C4H8O2.
ethyl,
Propyl methanoate. I don't know how to pronounce that.
Yeah, so it could be
ethyl,
propyl methanoate, right? It could be that. Yes, Haram?
ethanoate,
Ethyl ethanoate. Good, right? So it could be ethyl ethanoate. So it could be either one of those two. Polyesters are polymers made from dicarboxylic acids. Name the other type of organic compound used in the formation of polyesters.
Haram, you can have the highlight.
Spotlight.
Yeah.
I don't know the answer.
Oh, okay.
Okay, so esters are from acids and alcohols, right? So polyesters are made with dicarboxylic acids, right? So that's the acid part. What about the alcohol part?
Mm, it would be dialcohols,
No, it's called
diols.
diol.
Yeah.
And name the type of polymerization used in the manufacture of polyesters.
Condensation, polymerization.
Good.
Yay.
and we're done.
Oh, okay.
Good job.
Question: the for chemistry, the periodic table will be given at the end of the
Yes.
Okay.
Paper 1, 2, so I mean paper 2 and 4, and with paper 6, I believe as well.
Okay. So basically, in all papers
Yes.
for what I'm about to do. Okay.
Yes. Okay, so we're done with this. So tomorrow we will then take a look at the ATP.
At what?
ATP,
Alternative practical, I guess.
alternative to practical.
Oh, yeah. Okay.
All right.
Okay.
And once we're done with that, probably not tomorrow in its entirety, but once we're done with that, we'll have completed one round, and we will have been introduced to all the papers and the question types. Well, not all the question types, but all the papers and the kinds of questions you can get. Right? So
Okay.
after that, we can decide about which paper to focus on first. I think your paper 4, the theory paper, is first. Then is your paper 6, which is the ATP, and then finally you have your MCQ, which is paper 2. Right? So we can focus on our preparation accordingly.
Okay.
All right?
Yeah.
Yeah. So I'll see you guys tomorrow, and we'll start with the ATP, inshallah.
Inshallah.
All
Okay
right.
then. Allah Hafiz.
Good job.
Thank
Allah
you.
Hafiz.
Allah Hafiz.